All right, today we're talking about system of linear equations. There's going to be two parts with this. The first part is going to talk about where there's two variables, x and y, and the second part is going to talk about with three variables, x, y, and z. All right, so, well, all system of linear equation means is that what if we had two lines or more than one line, okay? So when there's more than one line, what can happen? Well, only a couple of things could happen. Situation number one. In situation number one, what if a line ends up being on top of each other? Okay, so they're literally laying on top of each other. If that's the case, they have a bunch of points that actually meet each other, right? We call that infinite number of solutions. Okay? What's the second possibility? The second possibility is, what if two lines just happen to be parallel to each other, so same slope, different y-intercept, so therefore they're never going to touch each other? Well, in this case, there'll be no solution. And then third possibility is going to be where two diagonal lines happen to cross each other. In this case, there is going to be one solution, and that one solution will be a point x comma y. So in other words, you will actually find a value for x and a value for y and know what point these two lines will cross each other or meet. Okay? So let's take a look at some examples that would demonstrate what these would look like if we were to use these systems of equations. So again, it's more than one line. So most of these equations, you're going to have two variables, two unknowns, x and y, so therefore you would need two equations. So most of these problems you will see two equations. All right, so let's do the first example that would demonstrate one. All right, the infinite number of solutions. So infinite number of solutions. Oops. Okay, so let's do that. Let's underline that just so that we see that. Boom. All right, so let's take a look at that. So they might give you these two equations here. X is equal to 3y plus 2, and 4x minus 12y is equal to 8. Okay, so there's two ways of solving this. One is called substitution. And the way we look at substitution is that when we are looking at the coefficients of each variable, we want to find the one that has a coefficient of 1, if possible. Because if we were to solve for, let's say, this y over here, we're going to end up with a bunch of fractions, which is definitely not anything fun. So let's try to avoid that. So if we can find one that has a coefficient 1, then it's going to be a lot easier. So for example, this, which is great because if you look at this, not just the fact that it is a coefficient 1, but it already got x by itself, even better. So we're going to use substitution here. So this is what substitution will look like. So we're going to use substitution. So what I'm going to do is I'm going to change this equation right here into red. Ooh. Let's try to change the whole thing into red. Oops. Let's try again. There we go. Let's change it all to red. Okay. So what do I mean by substitution? I'm going to take the first equation and I'm going to substitute it into the second equation. So what does that look like? So what it's going to look like is this. I'm going to take 4, and they tell me that x is equal to 3y plus 2. And minus 12y is equal to 8. Okay, so I'm taking the first equation, which tells me that x is equivalent to 3y plus 2. So I'm going to replace that, the x in the second equation, with the 3y plus 2. So there we go. So now I don't have an x to solve for. I have y, one equation. I can solve for y, so that's what I'm going to do. So the first thing I have to do here is I have to distribute. And after I distribute, I'm going to get 12y plus 8 minus 12y equals 8, right? All right, so if that's the case, look at what happens. I get, look at the 12 y's. They go away. So my y disappeared. I already got rid of x. The y disappeared. So I get the result of 8 is equal to 8. Okay. Now, 8 is equal to 8. That is absolutely true. So this is called a true statement, which means that these two lines that were given to me were actually the same exact lines, meaning they have the same slope and the same y-intercept. So therefore, in this case, there is an infinite number of solutions. Okay, so if I get a true statement and the x and y both disappear, that means I have infinite number of solutions. Okay. Case number 2. Case number 2 is that the fact that there is no solution. All right, let's take a look at that. When is it the case of no solution? So let's take an example of this system of equations. So let's go with 6x minus 10y equals 17, and 3x minus 5y is equal to 5. Okay? So the other way of solving for system of equations is using elimination. So I'm going to use elimination here. Okay? So this is, we're going to use elimination. And plus, I probably don't want to use substitution because when I look at these coefficients, none of them are equal to 1. And plus, if I can look ahead and try to solve for, let's say, this y right here, I'm going to get a bunch of fractions, so it's just going to be ugly. So let's use elimination. Elimination just means that after the first step, what I want to do is I want to eliminate one of the variables. I want to end up being just one variable, okay? So to do that, what I want to do is look at these coefficients. If I want to get rid of x, I'm going to look at these two and say, okay, what do I need them both to be so that I can, when I add them, it will cancel each other out. So the top I have a 6 and the bottom I have a 3. So if I multiply the bottom by a -2, I'll get a -6. So a positive 6, -6 will cancel each other out if I decide to multiply the bottom by -2. Now, if I was to look at these two here, right, top is a -10, bottom's a -5. So I would just multiply the bottom by a -2 to make it a positive 10, and -10 will cancel each other out when I add them. So I have some decisions to make. Either one is fine. You can make that choice yourself. I'm going to choose to multiply the bottom by a -2. So I'm going to multiply the bottom by a -2, okay? So the bottom is going to give me a -6x plus 10y is equal to a -10. Okay, so I got to multiply every single term, left and right side of the equal sign, by that -2. The top I didn't do anything with. There are going to be situations where you're going to have to multiply the top and the bottom by something to make it work. It's almost like finding the least common multiple between those two coefficients. So the top I'm not going to multiply anything, so it's just as is. So that's 6x minus 10y is equal to 17. So I'm going to add these two. And what you will notice is that what happens, look at the left side. Positive 6x, negative 6x, awesome. They cancel, and that was our goal, or my goal. And then, but the 10, or the y, happened the same thing. So on the left side, I have a 0, and on the right side, I have a 7. Well, is that a true statement? Absolutely not a true statement. This is a false statement. And it's a false statement because 0 is never, ever going to equal 7, right? So if it's a false statement, it just means that these two equations that was given to me were two lines that had the same slope, but different y-intercepts. And that's the reason why you get that 7 or any other number that 0 doesn't equal to, okay? So in this case, when it's a false statement, I have no solution, okay? So again, true statement, let's do this. So true statement, infinite solutions. False statement, no solutions, okay? There we go. All right, so now we're left down to the third situation, which is the one solution. And let's do a couple of those examples now. All right, so here, so number 3. So this is the third situation. Let's do a couple of those. So let's do 2x minus 3y equals negative 4, and 2x plus y equals positive 4. All right, so I'm going to actually show you this two different ways. One with substitution and one with elimination. Okay, so I'm going to copy this. There we go. Now I gotta go back to draw. Still working on it. All right, so I got two ways of doing it. I'm going to do it both ways, and here we go. All right, let me see here. Got it. All right, so if I was to do this, let me see, which way do I want to go first? Let's do it this way. Let's do substitution. So I want to do this with substitution. Okay, so with substitution, I am looking at the coefficients to see if there is one that's equal to 1. Voila, I do. Look at that. So I'm going to solve for this y. All right, so actually let me do it this way. I'm going to solve for this y. So I'm going to make this a red equation. So this is going to be, let me rewrite the first one. So the first one was 2x minus 3y equals to negative 4. And on that one, when I'm solving for y, to get y by itself, y is going to equal to negative 2x plus 4 because I'm subtracting 2x to the other side. Okay, great. Now I'm going to substitute the y equivalent into that first equation. So I'm going to have 2x minus 3 times negative 2x plus 4 equal to negative 4. So you guys got to be careful. So now I have to distribute that negative 3. So what do I have? I have 2x plus 6x minus 12 equals negative 4. So I can combine like terms. So I have 8x minus 12 equals negative 4. So 8x is equal to 8. So x is equal to 1. So there's part of my solution. So notice that in the first two examples, right when we try to do something, we got rid of x and y's are gone, and then we get either a true statement or a false statement. Where here in the third situation, I found an x value, right? Once I find an x value, that means there has to be a y value, okay? So the top two situations are now no longer on the table. So to finish this up, the appropriate thing to do is to substitute this 1 for x into one of the two original equations. That's what you should do, okay? So I'm going to take that second equation, all right, which is, so 2x plus y is equal to 4. So I'm going to substitute that 1 in, so I got 2 times 1 plus y is equal to 4. So that means I have 2 plus y equals 4, so y is equal to 2. Okay, so with that being said, that means my solution and where they meet is 1, 2. That would be my solution. And remember that every point that we have is x, y. That it would be a coordinate point, okay? So let's check this solution versus our elimination method, okay? So let me do this. We'll make it nice and strong. And, ooh, that's not what I want to do. Okay, that looks pretty good. All right. All right. Now I want to lasso this. Move this over so it gives me a little more room. Awesome. All right. So on this side, I'm going to work on elimination. So again, elimination, I got to choose. Do I want to get rid of x or get rid of y? Now, here's a situation as well. Now you can eliminate one of the variables, solve for, so I can eliminate the x, solve for y, and plug it in. I can definitely do that. I tend to find that I can just do double elimination, meaning I'll go through these two equations, eliminate the x, solve for y, go back to the original two, eliminate the y, and solve for x, all right? So I'm gonna show you guys what that looks like. So let's say elimination, and I'm gonna eliminate, let's say the x, okay? So if I wanna eliminate x, I'm going to look at these two coefficients. Same coefficients, if I add them, it become 4. So I want it to go away, I want to eliminate them. So if I want to do that, need those to be opposite signs. So in order for them to be opposite signs, I would have to multiply 1 by -1. So it looks like the top one would be best to multiply by -1. So I'm going to do that. And you're probably asking why. So the reason why I'm doing that is because I see a bunch of negatives in there. If I multiply by -1, those are going to turn positive. So it's going to be easier to add. So I'm going to write that down here. Let me see, how do I want to do this? Okay, I'm going to write it below. So, actually, let me do this first. Undo, because I got a feeling about this. Oops, oh, that worked. So, ooh, I can just paste it again. There we go, okay. So, I know I'm going to need this again because I'm going to eliminate the other one. So Let's go back to this. So again, I'm going to multiply this by a -1, all right? And now I'm going to put it underneath here. So what's that going to equal to? That's going to look like this. -2x plus 3y is equal to 4. Bring that one down. I have 2x plus y equals 4. So now I'm going to add these two. And when I add these two, look at the x's. One's a -2x, one's a +2x. That, when I add, goes away. So what I have left is a 4y equals 8. So y is equal to 2. Okie doke. Then I go back to the drawing board, bring this back up. Now, so what I did so far was that I eliminated the x, found y. So now I have to do elimination. And I'm going to do it to the y. So that means I'm going to look at the y value here and the coefficient there. So I have a -3 and a +1. Awesome. So if I have a -3 and a +3, it will go away. So that's what I'm going to do. So I'm going to multiply the bottom one by just a plain old 3. Because if I get that, then I got +3y, -3y will cancel each other out. So in this case, I'm going to rewrite the top one. So 2x minus 3y equals -4. The bottom, because I'm multiplying by 3, I'm going to get 6x plus 3y equals 12. So let me put that line underneath and add these two. What do I get? I have 8x, -3y, +3y, cancels each other out, is equal to 8. So my x is going to equal to 1. I wonder if these are the same answers. Oh, look at that. So even no matter which way I do it, I still get the same answer of 1, 2 as my answer. Okay. So, and if you notice, either way I do it, it's about the same length. I'm not really, one is not necessarily faster than the other. I like elimination better myself, but there's some people that like substitution, and that is absolutely okay. All right. All right, so the next thing. So let me draw a line here. Actually, nah, let's just leave it. So let's talk about, before I get into 3 variables, there are going to be points in time that we're going to talk about cost and revenue. Okay, now cost and revenue is going to be a situation where it is 2 lines that cross each other. So what does that look like? So before I make that, we'll show you what that looks like. Let me draw some straight lines. All right, so let's draw this. And then draw this. So when you start a business, okay, and the first day comes, and chances are you already started spending money, right? You have to buy a building, you have to buy, the license, you have to buy, I got to hire employees, you got decoration, remodeling, and everything else. So on the first day that the store opens, you already are in the red. Okay, so you already spent so much money. So on day 1, you typically are up here with expenses, and obviously the expense is going to keep on going up. Hopefully you can keep it lower as you go. So because you got to keep the electricity on, you got to keep your employees and everything else. Now, that is your cost. Okay, now cost in function notation would be C of X. So anytime that you see C of X, it's talking about a cost. All right, let's say that this cost is $6,300 plus 28 times X. So let's say it is, That would be good. So let's say to get into this business, you had to give me $6,300. And what you're trying to sell is iPods. Or yeah, iPods. Why not? And you're buying each iPod from me for 28 bucks. Okay? So you started at $6,300, you gave me $6,300, so there is $6,300 lost, or out of your pocket, I should say, because cost will be out of your pocket, and then for every iPod that you're buying from me is also 28 bucks, so you gotta give me that money as well. Well, when you opened your store, you started with zero money, right? The store has not made any money, so it always starts at zero, typically, okay? Oops, let me do that better. So when you start the store, that's called revenue, and that's the money that is coming in. That's not out of your pocket, okay? So let's say that the revenue, so this is called the revenue, okay? And we usually call that R of X. And let's say you are turning around and you're selling these iPods for $37, a little cheap, but hey, you're gonna sell a lot. So you're making that part of the profit. Now, where these two lines meet is called a break-even point. Okay? The break-even point is where the money that you have put out and the money that has come in is the same. In other words, the cost and the revenue are the same, meaning when those two functions are the same. So I would just take the 6,300 plus the 28x and set it equal to the 37x. Okay, so I have 6,300 is equal to 9x. So x is going to equal to 900. So you will have to sell 900 iPods to break even. That's a lot of iPods. Good thing you're selling it for $37. That's why you're really, really, really busy. And hopefully that will come sooner than later. Okay, so there you go. So you might get these type of problems about cost and revenue, and that's all they're talking about. Again, if you look at this, you're still getting two equations, just like you would be up here, okay? And in this case, it's easier because you're just taking the cost function and setting it equal to the revenue function, and then you're just solving for X to see how many iPods you need to sell, how many discs you need to sell, and so on and so forth, okay? So, okay? All right, so now let's talk about system of linear equations with three variables. All right, so in this case, there's going to be two types. Okay, there's going to be two types of problems that you're going to see. Okay, so the first type is where they are going to give you three equations with three variables, X, Y, Z, or A, B, C. And they're going to give you, since there's three unknowns, they're going to give you three equations. So it's going to look something like this. Actually, let me write them out first. So it's going to be x plus 4y minus z is equal to 20. 3x plus 2y plus z is equal to 8. And then 2x minus 3y plus 2z is equal to negative 16. So they would typically do something like this. So what I'm going to do is I'm going to show this to you by labeling these equations. So I'm going to call this the first equation, the second equation, and the third equation. Okay? So I'm going to break this down in parts as well. So actually, you know what? Let's do this. Let's go backwards. Doom, 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 doom. Okay, I'm going to use these snazzy pens. I'm going to call this equation A, equation B, and equation C. Oh, that's kind of cool. All right, so and then we're going to break these down. So main part of step 1. I'm going to say we're going to try to get rid of one variable. Okay? So we want it down to 2 equations. And we get rid of one variable, then we should have 2 unknowns, which is the 2 variables, all right? So if I get rid of one, there should be 2 left, all right? So in order to do that, I gotta involve all 3 equations. So the best way to do this is going to be, I'm gonna use, because if I'm looking at these coefficients again, right? These coefficients here, and these coefficients here, and these coefficients here, okay? So I'm looking at all these coefficients here. So those are all important to me. So if I looked at just A and B, okay, equations A and B, look at what happens. If I was just to add those, the Z would just disappear. So that's what I'm gonna do. I'm gonna go, okay, I'm gonna take the easy route. I'm gonna take equation A and equation B, all right? And those 2 equations says x plus 4y minus z is equal to 20, and 3x plus 2y plus z is equal to 8. And I don't have to do anything. I just need to add. And if I add these 2, look at what happens. I get 4x plus 6y is equal to 28. My z disappears. My z cancels out because it's negative z and a positive z. Goes bye-bye. So therefore I have, now this equation here has no z's. So I need one more equation. And I gotta get equation C involved here. So if I look at equation C, I have a positive 2z here. So for me, I want to take that negative and utilize it somehow, but I need that to be a negative 2, right? So I'm going to do this. Let me see how much room I have. Perfect. So I'm going to take negative 2 and I'm going to multiply it to the equation A. I'm going to leave B as is. I'm sorry, not B. Let's try that again. We're going to do equation C as is, okay? If I multiply equation A by negative 2, what do I get? I'm going to get a negative 2x minus 8y plus 2z, which is not what I want. So let's go back again. Let's just do it by just a 2. That's what I meant to do, sorry. So 2x plus 8y minus 2z is equal to 40. And then I'm just going to write down c as is, which is 2x minus 3y plus 2z is equal to negative 16. All right, that's much better because that will actually get rid of the z variable. So I'm kind of forced to take that z variable now because in my first look at everything, I already got rid of the z. So now on the second equation, because I need a second equation, I can't have z in it. I gotta get rid of z as well, so I'm left with just the x and y as my two unknowns or two variables. So when I add these two, I'm gonna have 4x plus 5y, and look at my z's. Goes away, negative 2z, positive 2z, no more, is equal to 24. Awesome. So now I have two equations, two unknowns. Sounds familiar. So now what I want to do is, so essentially what I have now is this. 4x plus 6y equals 28. And 4x plus 5y equals 24. So what I'm going to do here is take this bracket, move it over, so gently. And then I'm going to call this, since I have A, B, C taken already, I'm going to call this D and this E. Okay? Equation D and equation E. So I get to my second step. So step 2. Step 2, I want to get rid of one more variable, so I can find, in this case, find values for, in this case, my x and my y. All right. So just like I did when there was two variables. So this is the same thing as what I started with in the very beginning. Okay? So here we go. So I have D and E. So let me do this. Select this here. Okay. Let's try again. Select this here. Uh-oh. I guess I can't select that, huh? All right. That's not what I wanted. Delete. Select this here. Ooh. Hey. Copy. Insert. Paste. Awesome. Go away. Draw. Select. So let's bring this over here. Excellent. So, so when I look at the coefficients, the easiest thing to get rid of, again, I wouldn't want to use substitution here because nothing looks pretty. It doesn't matter which x I solve for, which y I solve for. It looks like it's going to be all types of fractions, and I know that you guys love them so much, but I would urge you to stay away from them. All right. So I would want to use elimination here. All right. So I wonder if I should show both eliminations, eliminate the x and eliminate the y, just to show you guys, because one of them you're going to have to multiply both equations. So maybe that would be a good idea. So let's go ahead and do that. So let's start with elimination. So I'm going to write down elimination here. So I'm going to start with eliminate x. Okay? So if I was to eliminate x, I I'm looking at the 4 right now, right? They're both the same coefficient, but one needs to be negative. Does it matter which one's negative? No, it does not. So I'm going to do this. I'm going to leave D alone. And what I'm going to do to E is I'm going to multiply E by that -1. So D stays the same. So that's going to be 4x plus 6y equals 28. And my E is going to be -4x minus 5y equals to -24. All right? Doesn't matter which one you multiply by negative. No, because if you multiply the D by -1, it flips all those signs, and when you add them, the x still goes away. And you're still going to get the same y value anyway, so it really does not matter. All right? So let me try this again. There's that line. Awesome. And what do I get? Look, the x goes away. I'm left with a y is equal to 4. All right? So I got to remember that. Y is equal to 4. Awesome. So let's come over here and let's eliminate the y. Okay, so now let's look at the coefficient of the y. The coefficient of the y are +6 and a +5. I need to make them the same number. And the only same number that I can make them to be is going to be 30. Okay, because if I go through the multiples of 6, 5 doesn't go into, then it's going to be 12, 5 doesn't go into, then it's going to be 18, 5 doesn't go into, 24, 5 doesn't go into, 30, 5 does go into it, and 6 does go into it. So I'm going to, question is which one do I want to be negative, all right? So that's the only question, and it doesn't matter, all right? So what I'm gonna do again is I have a D equation and an E equation. So let's multiply the top one by -5 and the bottom one by a 6, because -5, here, let me show you, -5 times a 6 is going to give me a -30. A +6 times a +5 is going to give me a +30. So -30, +30, voila. Okay, so I'm on top, multiply the D with, actually, you know what I'm going to do as well? Let's change this to a blue 6. There we go. So that I can differentiate the two equations here. So I'm going to multiply the D equation by a -5. So that's going to give me a -20 x, -30 y is equal to a really big number. That is going to give me 1 times 28, -140. All right. And the blue, so 6, I want to multiply the E by. So that's going to be a 24x. 6 times, so it's going to be +30y is equal to 144. And that is going to be a +144. Okay, awesome. So now let's do this and add them. All right, so what do I have? I have a 4x, my y goes away, awesome, is equal to 4. Huh, all those big numbers, I was worried. So there is my 1. So x is equal to 1, awesome. So I got x equals 1, y equals 4. Beautiful. But I'm not done. So notice how this problem becomes fairly long. So there's step 1, step 2. Now we're going to get into step 3. So what's step 3, you ask? Well, step 3 is to find the value of z. Because we already found x and y, so now we just need to find the value of z. And I do not like that writing at all, so let's rewrite it. There we go. That looks way better. All right, so how do we do that? So I'm going to come back up here. I'm going to select really nicely that, and I want to copy that. I want to come down here, tap there, paste there, awesome, and bring that over here. Okay, so I'm going back to where it all began. Now, so what I do know already, oops. What I do know already is that I have x is equal to 1 and I have y is equal to 4. That is what I know. All right. So what I'm going to do is I'm going to enter x equal to 1 and the y equaling to 4 into one of these equations. It does not matter which one you choose. You can choose A, you can choose equation B, you can choose equation C. It really doesn't matter. So let's do, I think, the easiest one, equation A. All right, so let's look at equation A. So if I do that, I'm going to have 1 plus 4 times 1 minus z is equal to 20. Oops, sorry, that is not a 1 in here. It's actually a 4 because that's a value of y. All right? All right, so now let's solve for z. So I got 1 plus 16 minus z is equal to 20. 17 minus z is equal to 20. Negative z is equal to 3. So if negative z equals to 3, then positive z was equal to negative 3. All right? So with that being said, that means, now notice what they're asking. They're looking for the value of x, y, and z, meaning these three lines, where do they meet? All right, so my answer is they meet at the point of 1, comma, 4, comma, negative 3. There you go. So that's how I would do 3 equations, 3 unknowns. Pretty long. So that is the first type you're going to see. 3 steps, but the first type. Okay? So let's do the second type. So what is the second type? Well, the second type, you're going to be given these things here. So you're going to be given an equation like f of x is equal to ax squared plus bx plus c, or this is also known as y is equal to ax squared plus bx plus c. All right, remember that. So it's given an equation and 3 points, meaning when x is equal to 1, y is equal to 4. When x is equal to 2, y equals 1. And when x equals 3, y equals 4. All right? So they might give you something like this. So when they give you something like this, it's not too bad because you're not really sure where to go. But here's the cool part. I have 3 points. That means I can create 3 equations, right? I have x's, I have y's. What's unknown is my a, b's, and c's. So if there's 3 variables right there, a, b, and c, that are unknown, that means I need 3 equations. Good news is I have 3 points. So how do I come up with those 3 points? So let's do it this way. I'll call this point A, point B, and point C. Okay? So if that's the case, then I'm going to plug in point A. So point A, I'm going to plug it in. So that's going to give me 4 is equal to, actually, you know what? Let's do it this way. Undo, 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 undo. Okay, so I'm talking about the point 1, 4, right? So I'm going to plug that in. So what I'm going to have is 4 is equal to A times 1 squared plus B times 1 plus C. So there's 1. I'm going to take point B, which is when x is 2, y is 1. So that's going to tell me that 1 is equal to A times 2 squared plus B times 2 plus C. And then point C tells me that when x is 3, y is 4. So that's going to be 4 is equal to A times 3 squared plus B times 3 plus C. All right, so there you go. So there's my 3 points. And I'm going to stick with those points and call those equations the A, B, and C as well. So I got plenty of room here. So I'm going to call A here 4 is equal to, well, 1 squared is 1. So that's A plus B plus C. My B equation here is going to be 1 is equal to 2 squared is 4 times A is 4A plus 2B plus C. And my C equation here is going to end up being 4 is equal to 3 squared is 9A plus 3B plus C. So again, I'm going to call these my A, B, and C equations. Okay? So B, the C's are pretty consistent. So I'm going to do, let's do it this way. Again, our first step is to try to get rid of one of the variables, right? So I'm just going to write down step 1. And I'm going to say get rid of C. Okay? So, okay. So I'm going to do, I need 2 equations. So I'm going to do A and B. Why not? And how do I want to do this? So if I look at A and B, I can get rid of, these are probably poor choices in terms of A and B. When I'm looking at the first 2 equation here, equation A and equation B, I could just get rid of the C as long as one of them is negative. So that's probably the easiest way to go. So which one do you want to be negative? I'm going to make the B negative. So I'm going to keep equation A, and I'm going to take the B and I'm going to multiply it by -1. So A is going to stay the same, which is 4 is equal to A plus B plus C. I'm going to multiply the B equation, or the second equation, by a -1. So that's going to be -1 is equal to -4A minus 2B minus C. Then I add them. And what do I get? I get 3 is equal to negative 3a minus b. And the c goes away. Awesome. So my next question is, what's the other two equations that you want to use? I know the fact that the c equation has to be used. Question is, do you want to do A or B? Heck, because the other one we use the first and second, first and third, let's use the B equation, okay? So let's use those two. So let's look at the coefficients here. Same thing, one's positive, one's negative. Question is, which one do you want to be negative? Well, let's stay consistent. Let's keep on multiplying the B by negative 1. So let's take the B and multiply by negative 1. And what is that going to give me? If I multiply the b by negative 1, I already have it down here. So I'm going to have a negative 1 is equal to negative 4a minus 2b minus c. And the third equation is going to stay as is, which is 4 is equal to 9a plus 3b plus c. All right. So when I add those two together, this line is bugging me. Sorry, guys. This line is bugging the crap out of me. That's better. Not great, but better. All right. So what is this going to give me? This is going to give me 3 is equal to 5a plus b. All right. Awesome. Man, this worked out nice. Look at that. That purdy. All right. Let's see here. Okay. So I have these two equations left, right? And we call these two equations D and E, right? So D and E. So equation D was 3 is equal to negative 3a minus b. And equation E was 3 is equal to 5a plus b. All right? And before I do that, let's move this down a little bit because I need to do, undo. There we go. So we need to go to step 2. Darn it. We'll bring this down even more. 2 right there, and I'll bring this over here. All right, so let's call step 2. Well, when you look at this, I want to say get rid of B, right? So look at this. I don't even need to multiply by anything. I just got to add these two equations. Look at that. So nice. So what do I get? I get 6 is equal to 2a, and the b cancels out. So I got a is equal to 3. Awesome. Okay. So now, plug it back in. So does it matter if it's D or equation E? Not really. So let's do that. So let's just plug it back into E. So let's take this and this. So I get 3 is equal to 5 times 3 plus B. So 3 is equal to 15 plus B. So B must equal to negative 12. Okay, awesome. I have A and B now. So now I'm ready for step 3. Find Z, right? So to do that, I had to come back up here. Let's do a nice little select here, right? Copy. Paste. Awesome. So the question is, I have, undo. So I have here that I need to find Z. since, why am I finding z? Why don't I find c instead? That's a good idea. So my a is equal to 3, and my b is equal to negative 12. So I think the easiest one to put it in is the very first one. So let's do that. Let's plug it into the first one here. All right. So I have 4 is equal to 3 plus negative 12 plus c. So that means I have 4 is equal to negative 9 plus c. So that means c is going to equal to 13. Okay? So now I have my a, my b, and my c. And don't forget, this is not asking for where the point that they cross. I was given an equation and it's asking me to find a, b, and c. Okay? So that means I'm looking for, so my answer would be y is equal to 3x squared minus 12x plus 13. That would be my answer. All right. Now, notice that the first time through this was seemed a lot longer because we were going kind of through the steps and everything else, where the second one kind of went pretty fast. So I want you guys to understand that it's not going to be too bad. You just got to get some practice in. I don't think it's hard. I think it's long. Okay. If you have any questions, you know how to get a hold of me.